These are the video notes for systems of equations. In a system of equations, the solution will be the x and y values that make both equations true. And on a graph, it's the point of intersection, where the two lines meet. To find the solution, there's a couple of different ways you can use. One method is by graphing both equations. Let's look at this first example on the left. This first equation is in slope-intercept form, so it's easy for me to see the slope and the y-intercept. If it's negative x plus 4, the slope is going to be negative 1, and the y-intercept is going to be 4. So on the graph on the right, starting at a y-intercept of 4, and then slope of negative 1, so down 1 to the right 1, down 1 to the right 1. Second equation is in standard form. So one thing I can do to graph that second equation is rearrange it into slope-intercept form. So I'm going to get y all by itself. Right now, y is negative and there's a positive 2x. So I'm going to undo this positive 2x by subtracting 2x from both sides. So then I would have negative y is equal to negative 2x plus 2. Then to undo this negative, I'm going to divide by negative 1. Keep it balanced. Do the same thing to both sides. So then on the left, I have positive y is equal to negative 2x divided by negative 1. The two negatives will cancel out, so I'm left with positive 2x. And then positive 2 divided by negative 1 is negative 2. Now I've rearranged the equation into slope-intercept form. I know that the slope is going to be positive 2, and the y-intercept is going to be negative 2. So let's graph. Starting with the y-intercept of negative 2. I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, and so on. I can connect these points. And my solution is right here, where the two lines meet. And that's an x of 2 and a y of 2. In this example, we graphed both equations by hand. On the STAR test, once you have both equations in slope-intercept form, you should use your graphing calculator to produce the graph, or you can use the Desmos graphing calculator on your test too. Another way to solve is by using substitution. And substitution works well when you have one variable all by itself, or one variable isolated in one equation already. We have that in this bottom equation. X is equal to 3 plus y. So 3 plus y is all equal to x. So what we can do is we can take all of that and substitute it in for x in this first equation. So if we did that, this first equation would become 4 times x is now 4 times 3 plus y, because that's what we substituted in for x. And then the remainder of the equation is plus 2y equals 14. Then I'm going to use distributive property to simplify this left part. So it's going to be 4 times 3 and 4 times y. So 4 times 3 is 12, times y is 4y. And then the remainder of the equation, plus 2y equals 14. I can combine like terms, the 4y and the 2y. So this would be 12 plus 6y equals 14. I want to get y all by itself. Right now y is being multiplied by 6 and added with positive 12. So let's undo the positive 12 by subtracting 12 from both sides. So then I would have 6y equals 14 minus 12 is 2. Y is being multiplied by 6, so I want to undo that. I'm going to divide both sides by 6. So y is equal to 2 over 6. That fraction can be simplified to 1/3. Now I know what y equals, but my solution is an x value and a y value. So to find the other variable, I'm going to substitute this y value of 1/3 in for y in either one of the two equations. You can choose which equation you use, but a lot of times one equation is easier to use than the other. In this case, the second equation, x equals 3 plus y, is a lot easier to use. So let's do that. So the second equation, x equals 3 plus y. But now I'm substituting 1/3 in for y. So x equals 3 plus 1/3. So my x value is 3 1/3. And my final solution then is an x of 3 1/3 and a y of 1/3. If these two equations were graphed, this is where they would intersect. A couple of other quick notes about systems of equations. Some special cases. If you graph the two lines and they're parallel to each other, so they have the same slope, then those two lines would never intersect. And in that case, since there's no point of intersection, we would say that there's no solution. If your graph looks something like one line is like this and the other line is like this, parallel, no point of intersection, no solution. The other special case that you can have is if the two lines are the same line, so they're on top of each other, then those two lines are constantly intersecting. So we would say that there are infinitely many solutions.